Last class, we began Big Ideas, Section 1.2, Part 1, looking at single transformations of absolute and linear functions. Today, we're going to look at multiple transformations through examples. As a quick review, we filled out this little table last class period. Remember that if you add or subtract a value outside the function, that it will move your graph up or down k units. If you add or subtract on the interior of the function with the x, it moves it left and right, but it's the opposite of what you would think. If you multiply by the absolute value of a such that it's greater than 1, it is considered a vertical stretch of a. If you multiply by a value of a that is absolute and is less than 1, it is a shrink of a. If you multiply an entire function by -1, it's a reflection in the x-axis or across the x-axis. If you change the x value within a function, it will reflect it across the y-axis. So what we're going to do is a series of examples. If you look at the first example, we do f of x equals x. That is considered a linear function. It says we're going to do a vertical stretch by a factor of 8, followed by a translation of 10 units down. So to start with, we need to start with the stretching by a factor of 8. So if you remember, to stretch by a factor of 8, the notation for that is 8 times your function. So what we're going to do is we're going to take 8 times my x, which is 8x. Now after we've done that, it says we're going to translate it 10 units down. So we're going to take this function, and if you remember, the function is basically you take your function and we subtract 10 units down. That means we're going to take 8x minus 10. Well, you can't combine the two, so I'm just going to use g of x as my new notation. The new equation is 8x minus 10, and leave it. So there's the first example. Example 2, we're going to do the same, but this time we're going to do it with an absolute value of x. It says we want to translate us 6 units down, followed by a reflection in the x-axis. So we start with our function, absolute value of x, and we want to translate it 6 units down. So the notation for that would be f of x minus 6, because we want to move it 6 units down. So f of x is the absolute value of x, and then it says minus 6. Okay, we've moved it 6 units down. Now it says it wants to reflect across the x-axis. Remember, the notation for reflecting across the x-axis is not f of negative x. To reflect across the x-axis, we take -1 times the function of x. So we're going to take this times -1. We distribute. Remember, you can't distribute inside the absolute value, so that's -1 absolute value of x. -1 times the -6 is a positive 6. Remember, -1 absolute value of x is just the same thing as saying negative absolute value of x plus 6. And then we give it some new notation, g of x. So there is example 2 for you. Example 3, we're going to take our linear function x. We're going to vertically stretch by a factor of 2, followed by a translation of 1 unit up. So we break it down. First thing we're going to do is a vertical stretch of 2. Remember, that's 2 times our function. So we're going to take 2 times x, which is 2x. And then it says we're going to translate it 1 unit up. And if you remember the notation for translating up 1 unit, it's f of x plus 1. So in this case, since we have 2x, it becomes 2x plus 1. That's our new function. These aren't too bad to do. Just need to break them down a little bit. Next one. Given the linear function f of x equals x, translate 3 units down followed by a vertical shrink by a factor of a third. So this time it's going to have us move it down first and then shrink it. So we start 3 units down. Well, to do 3 units down, it's f of x minus 3. So if f of x is x, so it becomes x minus 3. Then it says vertical shrink by a factor of a third. And if you remember that, that's where we take a third times our function. So we're going to take a third of this function. Well, we got to distribute. 1/3 times x is 1/3 x. 1/3 times negative 3 is negative 1, and that becomes our new function. Now remember, you can use Desmos to double check your operations, but you have to remember things do move around when you stretch them and when you shrink them and move them up and down. Next one. Function f of x equals the absolute value of x. Translate 2 units to the right followed by a vertical stretch of 2. Okay, 2 units to the right. Well, in order to do that, it says it's normally x, but then the opposite of it. So 2 to the right. So we're going to plug it in to our absolute value. So where it says the absolute value of x, we're going to put in x plus 2. Now it says a vertical stretch of 2. Well, vertical stretch of 2 means 2 times whatever you got for f of x. So if this is my f of x times 2, okay, can't distribute in front, but there's like an imaginary 1 there. 2 times 1 is 2. So we can become 2 absolute value of x plus 2. Be careful in the order. Be careful in the order. Whatever it lists first is what you do. Next one, reflection in the y-axis followed by a translation of 3 units to the right. Okay, reflection in the y-axis, if you remember, means we replace negative x for x. So if it's absolute value of x and we're putting a negative x in, well, what is the absolute value of a negative x? Well, it's just plain x. No biggie. So really it doesn't change it. Followed by a translation of 3 units to the right. Well, that's normally x minus 3. So we're going to replace with x minus 3 where we see x. So there's my new function. So we flipped it and then we moved it right 3. For the last problem, I'm going to just come up with one. Say we have a function that is linear, and now we're going to kick it up a notch. 3x plus 2. Okay, maybe we want to stretch by, sorry, I should have said vertical stretch. Vertical. Stretch by a factor of 3. Followed by translating 2 units up. Okay, so we start with the problem and we say here's our function. We want to stretch by a factor of 3. So that means we take 3 times our function. So that's 3 times 3x plus 2. Which is equivalent to 9x plus 6 when we distribute. There's my new function. Now it says take that new function and to that, move it up 2 or translate it up 2. Well, the notation for translating up 2 is f of x plus 2, where we just add 2 onto our function. That just becomes 9x plus 8. And there is my final function. So it doesn't just have to be x or absolute value of x. it can work the same way. So let's do one more. Last one. Say I have the function 2 absolute value of x minus 1 plus 7. Okay, so first thing I'm going to do is I'm going to move it right 4. Translate it right 4. Then I'm going to move it down 6. And finally, I'm going to do a vertical shrink of 1/2. Okay, so anytime I do something, I'm going to do it in a different color so you can see it. First thing I see is right 4 units. So that is f of x minus 4. Okay, so where that says we're going to do is where we see x, we're going to put in x minus 4. So my new function becomes 2 absolute value. Now where we see this x, we're going to put in x minus 4. And then it says subtract 1 more in the original problem, and then add 7. Well, that reduces to 2 absolute value x minus 5 absolute value plus 7. Okay, after it says to do that, next thing we're going to do is move it down 6. Well, to move a function down 6, we just do f of x minus 6. So I'm going to take my function, and it says all I'm going to do is subtract 6 off the end. Well, that doesn't change anything inside. The only thing it does do is take 7 minus 6, which is a positive 1. My final step says vertical shrink by a factor of half. So that means we take 1/2 times our function. So we're going to take half of that whole function. Now when we do that, we only multiply the coefficients. So 1/2 times 2 is just 1. So 1 absolute value. We never distribute inside the absolute value. So x minus 5. And then we do half of 1, which is a half. Now if you want to reduce that, all that reduces to is g of x equals 1 times anything is just the identity. So absolute value of x minus 5. Then plus 1/2. Hopefully this will help you with function notation and